Hi everyone, welcome to this video on getting started with the diagram component of Syncfusion in a Blazor server application. In this video, I will explain how to create a Blazor application and add the Syncfusion Blazor package. Then I will show you how to add the Syncfusion Blazor diagram component to the Blazor server application. Finally, I will show you how to create a simple flowchart using nodes and connectors. Now, let me create the Blazor project first. I can create a Blazor application either using Visual Studio 2019 or Visual Studio Code. In this video, I will create a server-side Blazor application using the Visual Studio 2019. Make sure that you have installed .NET Core SDK 3.12 or later versions. To follow along this video, one should have a basic understanding of C#, HTML, and CSS. Also, you can watch a descriptive video regarding Blazor and Syncfusion controls with the title Create a Blazor server app and add Syncfusion Blazor components, which I have shared in the YouTube card. Using Visual Studio 2019, I create a new project. I select the template Blazor app, provide the project name as My Blazor Server App, and click Create. Here, the Blazor Server app was selected by default, hence I proceed by clicking the Create button. Now, Visual Studio has generated a Blazor server application. To use the Syncfusion Blazor components, I need to install the Syncfusion Blazor NuGet package into my application. For that, I will open the NuGet package manager by right-clicking the project file and selecting the Manage NuGet packages. Under the Browse tab, I will search for the Syncfusion Blazor package. I select it and click the Install button. The installation has been completed now, and you can check it under the Dependencies folder and within the Packages folder. You can see the Syncfusion Blazor package added to this application. Next, I will register Syncfusion Blazor service in the Services container. For that, I open the startup.cs file and use the Syncfusion Blazor namespace. Within the Configure Services method, I make a call to the Add Syncfusion Blazor method. This makes Syncfusion Blazor services available within the application. Next, I will register a valid Syncfusion license key. To do so, in the configure method, I call the Syncfusion license provider class, static method register license. You need to pass your Syncfusion license key as a string parameter in the register license method. I have done this off screen. Within the pages folder, open the host.cs HTML file. Within the head tag, I need to add the required CSS file to render the Syncfusion Blazor components. In this example, I refer the CSS file from the installed Syncfusion Blazor package. Now, let me add the Syncfusion Blazor diagram in the index.razor page. To do so, I use the Syncfusion Blazor diagrams namespace. Adding this namespace here will allow me to use the diagram component markup in this index.razor page. Also, I can import this namespace in the imports.razor page to make it available in all Razor pages within this application. I remove the existing code and type SF diagram tag and set the width and height of it. Let me save the file and run the application. You can see the diagram component canvas. Now, I will create a simple flowchart to print the word Syncfusion 10 times. To create a flowchart, I need to create nodes and connectors and link those nodes using connectors. Also, I need to define the default node and connector values for the diagram component first. To do so, within the code directive, I create a property of type diagram node and name it flowchart node defaults to set the default properties for my flowchart nodes. Next, I create a property of type diagram connector and name it flowchart connector defaults to set the default properties for my flowchart connectors. Now I will create a method and define these default node and connector properties. To do that, I override the onInitialized method, which will be called when the component is initialized, and within it, I will call the initDiagramDefaults method, on which I am going to define the default node and default connector properties. Next, I create a private void method initDiagramDefaults, and to the flowchart node defaults property, I create a new diagram node object and set the width, height, offset x, annotations, and style properties. To set value to this annotation property, I define the default annotation style with white color and fill it with the transparent style using the diagram node annotation class. Here, the annotation style defines the look and feel of the node. To access the observable collection generic class, I import the namespace system.collections.objectModel. To the SF diagram tag, I set its node defaults property with the created flowchart node defaults property. Next, I need to define the flowchart connector defaults property. So within the init diagram defaults method, for the flowchart connector defaults property, I assign a new diagram connector and set its type and target decorator options to display an arrow mark at its target end. In the SF diagram tag, I set its connector defaults property with the created flowchart connector defaults property. Now I will create nodes and connectors for the flowchart. First, I create nodes for my flowchart. To do so, within the code directive, I create a property of type observable collection of diagram node and name the property node collection to store the needed nodes. Then I will create a method and define these node collection and connector collection properties. In the onInitialized method, following the init diagram defaults method, I call the init diagram model method. Within this, I am going to create the node and connector collections. So I create a private void method init diagram model, and within it, for the node collection property, I set a new observable collection of type diagram node object. Before I start to create the nodes, first I will implement the create node method with a common code for node creation. Here, I am creating the node by using the diagram node object and setting few of its essential properties like ID, offset Y to set the position for a node, shapes to indicate different nodes, and the annotations to be assigned to the node by accessing the values from the parameter list. Also, I have defined the annotation for nodes using the diagram node annotation object. At the end of this method, I have added the newly created diagram node to the node collection list property. So this create node method acts as a common method to create and add new nodes. Now I call the method create node inside this init diagram model method and pass the ID for the node start with the offset Y position as 50, the flow shape as terminator to indicate the start of the flowchart and the annotation text as start. Now I have added a single node to the node collection list property. Let me add this property to the SF diagram tag. I add the nodes property and set the node collection property. Now let me run and see how this works. I save the file and run the application. You can see the start node in the diagram canvas. Next, let me add few other nodes required to design my flowchart. Here, as you can see the pictorial representation of my flowchart, I need to add 5 more nodes to my flowchart. So in the init diagram model method, I add codes to create these required nodes of my flowchart. I have added a process node to initialize the variable, a decision shape to check the condition for whether the value is greater than 10 so that it can print the text 10 times, then a node to print the value syncfusion, again a process shape for incrementing the variable, and finally a terminator shape to end the flow. Let me save this and run the application. You can see the nodes added in the diagram canvas. Now let me create connectors to connect these nodes. So in the code directive, I create a property of type observable collection of diagram connector and name the property connector collection to store the needed connectors. Within the init diagram model method, for the connector collection property, I set a new observable collection of type diagram connector object. Before I start to define the connector collection, first I will implement the create connector method to create connector elements. In this method, using the diagram connector class, I have created an object and set the ID uniquely. Also, I have set the source ID and target ID property assigning from the parameter value. I have added the annotation for connectors using the diagram connector annotation object reference. I also assign segments for the connector. I will explain the segments later in this video. At the end of this method, I have added the newly created diagram connector to the connector collections list property. So this create connector method acts as a common method to create and add new connectors. Now I add the code to create a connector inside this init diagram model method by calling this method create connector and pass the source node ID, start and target node ID init. This will add a single connector linking the start node and init node. Let me add this property to the SF diagram tag. I add the connectors property and set the connector collection property. Now let me run and see how this works. I save the file and run the application. You can see the start node is connected to the next consecutive init node with a connector. In this way, I can add other connectors as well to join all other nodes. You can notice that the connector with the annotation S and the connector from increment node to decision node need additional segments to depict the correct flow. To add such segments to the connectors, in the init diagram model, I create 4 diagram connector segments object with the desired type, length and direction. Now I need to pass these segments as parameter to the appropriate connectors using the create connector method. Hence I add the code to add segments while I implement the create connector method. In the create connector method call to the condition and end nodes, I additionally pass the segments to connect them. I do the same for the increment and condition nodes. Since this connection doesn't need any annotation, I marked it as null. I save the file and run the application. Now you can see the flowchart loops until the variable I reaches the value 10, and once done, it will end the flow. If you need more information about the Syncfusion Blazor diagram component, you can refer to our online documentation. A link is provided in the description of this video. Finally, let me summarize the main points. I have explained the steps to create a Blazor server application and add the Syncfusion Blazor package to the Blazor server application. Then I explained how to add the Syncfusion Blazor diagram component and showed you how to create a simple flowchart using nodes and connectors. You can download this working example from the GitHub link in the description for this video below. You can also see about getting a free license key to use our Blazor products if you are eligible for our community license. If you found this video useful, click the like button and subscribe to our channel to get notifications about new videos. Thanks for watching.